Good afternoon, students. In previous lecture, we studied the complementary symmetry power amplifier that is used to amplify the power level of the input signal by avoiding the input and output transformers that reduces bulkiness of the push-pull power amplifier and transistor used in complementary symmetry amplifier, where one is PNP, another one is a NPN, which may amplify the input power level in the same manner as the push-pull power amplifier amplifies the power. As a being, the circuit is symmetrical in upper and lower half, but the working of both the transistors are complementary to each other. That's why that circuit is named as the complementary symmetry power amplifier. Student friends, when we have studied the class B push-pull power amplifier, we said that class B push-pull power amplifier possesses a distortion, especially crossover distortion, and which is removed in class AB push-pull power amplifier. Now we are going to deal with the meaning of the distortion. Friends, distortion means deviation, variation, or change. That change, that variation, that deviation is known as a distortion. When we are going to relate the distortion to the power amplifier, we can say that it is the deviation in the output power of the power amplifier which is not present in the input. Means whatever the change in the power signal developed at that power amplifier, those variations, those changes are not present in the input. Or the deviation in the output power of the power amplifier which are not related to input. Such a variation which is present in the output of the power amplifier. So the deviations which are present in the output of the power amplifier are known as the distortion. Such a distortion arises because of nonlinear characteristics of active devices which are used in the construction of the power amplifier. And especially in power amplifier, we are using power transistor as an active device which has a nonlinear characteristics. Because of its nonlinear characteristics, output signal power deviates from the input signal power after amplification being done by means of the power amplifier. Such a deviation in the output signal which is not present in the input, which is not related with the input, that arises due to the nonlinear characteristics of the active device is known as the distortion. Friends, distortions are of the different types. Here some of the types are represented. One is harmonic distortion, second one is a frequency distortion, third one is phase distortion, and fourth one is intermediate frequency distortion. Especially intermediate frequency distortion is related with the electronic communication system, because in every receiver used in the communication system makes use of intermediate frequency amplifier to amplify the intermediate frequency that contains the difference between two input frequencies. And if at the output of that intermediate frequency amplifier, if that IF deviates from the input, then we can say intermediate frequency distortion is going to present in that particular communication system. Next one is a phase distortion. Phase distortion is a type of distortion in which the phase change in the output signal that occurs, which is not present in the input. For example, if you consider the case of common emitter amplifier, we are well aware that phase difference between output signal and that of input signal is 180 degree out of phase with each other. Those are not in phase with each other. We may going to consider this as a distortion. And this distortion is related to the phase, hence it is known as phase distortion. Next one is frequency distortion. Frequency distortion means change in frequency that appears at the output of the power amplifier, which is not present in the input frequency of the signal to be amplified. So such a distortion we can call it as it is a frequency distortion. Friends, but we are interested to study the harmonic distortion in detail. Harmonic distortion is a type of distortion which produces the fundamental frequency at the output along with some new frequencies which are not present in the input. At the input only fundamental frequency is there which is required to be amplified. Definitely it is going to be gets amplified. Its power level is going to be gets amplified and it is made available at the output of the power amplifier. But along with this fundamental frequency, some new additional frequencies are also going to be produced which are not present in the input, which are not related to the input. These new frequencies along with the fundamental frequencies are called as harmonics of the fundamental frequency. Hence the distortion produced is known as harmonic distortion. It is also called as amplitude distortion because there is a variation in amplitude is also takes place, or it is sometimes called as it is non-linear distortion, which arises due to the non-linear characteristics of the active devices. I hope you might be getting idea about the harmonic distortion. Once again I will repeat. Harmonic distortion is a kind of a distortion in which at the output of the power amplifier along with the fundamental frequency some additional new frequencies are going to be get generated, and these new frequencies are called as harmonics of the fundamental frequency, and that's why it is called as harmonic distortion. But please do remember that these newly obtained frequencies are not present in the input of the power amplifier. Such a distortion arises due to the nonlinear characteristics of the active device. It is also known as amplitude distortion. Let us see its detail. If suppose there is a voltage amplifier, for voltage amplifier, amplification is very less. So that's why such a type of the distortions are not visible as far as voltage amplifiers are being considered. But power amplifier level of amplification is more, hence the distortion is appearing at the output of the power amplifier, or it is visible at the output of the power amplifier. Means in power amplifier distortion appears to be more than that of the voltage amplifier. Friends, to understand the meaning of harmonic distortion in detail, let me consider input signal whose power level is to be amplified. We say Vi equal to V cos of omega t. that is applied to the any of the power amplifier. When this signal is given to the power amplifier, by allowing one of the transistor to conduct at a time and other transistor is going to be remains cut off, so that alternate this function that takes place by pushing and pulling action of the BJT, and the amplified output signal is made available due to the collector current passes through the load. That collector current, here we can call it as it is the output current. That output current after amplification is given as I-O. O for output, I for current. So output current is given as A0 plus A1 cos of omega t plus A2 cos of twice omega t plus A3 cos of 3 omega t, where A0 is the original amplitude of the frequency, A1 is the amplitude of the fundamental frequency, A2 is the harmonics of the same, A3 is the harmonics of the same fundamental frequency. All these components constitute the output current to flow through the load resistors. Due to these components of the current, the distortion at operating point due to this distortion, operating point of the BJT shifts on the load line. Hence, the working of the power amplifier is going to be hampering. This distortion is going to be represented as, let me suppose, due to the distortion due to I0 is the total output current, A0 is the exact component of the amplitude, A1 is the amplitude of the fundamental frequency, A2 is the amplitude of the second harmonics, A3 is the amplitude of third harmonics, and so on. Due to distortion present in the amplifier, the operating point shifts on the load line. The distortion due to second harmonics is given as a D2 equal to A2 upon A1 into 100, that is in percentage. So amplitude of the second harmonics upon amplitude of the fundamental amplitude harmonics is the distortion of second harmonics. Similarly, the distortion for third harmonics is A3 upon A1 into 100%, and so on. Please do remember, all these are of modulus values. Only positive values are going to be considered here. The total distortion D is given as a square root of D2 square plus D3 square plus D4 square, and so on, where D is the total distortion. The power obtained at the output is given as AI square upon 2 into RL, A1 square upon 2 into RL, that is a fundamental frequency, A2 square upon 2 into RL, plus A3 square upon 2 into RL. This gives the total power. Out of this, if you take A1 square of RL upon 2 common, then we can write it into bracket 1 plus A2 upon A1 bracket square plus A3 upon A1 bracket square plus A4 upon A1 bracket square plus so on. This can also be written as A1 square upon RL is the RL by 2 is the power due to fundamental frequency. So that's why it is represented as a P1, and hence we can say total power P is equal to P1 into bracket A2 upon A1 is D2, A3 upon A1 is D3, and that's why we can write it. P is equal to P1 into bracket 1 plus D square plus D3 square plus D4 square and so on, where P1 is A1 square RL upon 2. It is power due to the fundamental frequency. If you replace D2 square plus D3 square D4 square by D square, then we can write P is equal to P1 into bracket 1 plus D square, where D is the total distortion. Thus, harmonic distortion is present in the output of the amplifier, which is not present in the input. So thus we can say that there is a presence of distortion at the output which is not related with the input. Student friends, this is what you have to remember regarding the distortion in power amplifier, its types, their definitions, and also the details regarding the harmonic distortion. Friends, that's all about today's lecture. Next time we'll go for next aspect of the power amplifier.